Alright, this is the Module 8 similar questions video for the DBA, and I hope you find it useful. Make sure to come to class and ask questions if you're confused about anything. I will be happy to help. So in this first one, we are supposed to graph that function. The first thing I notice is that the constant here, that tells me what our y-intercept is. So we have a y-intercept here of 0, 8. After that, I can find the axis of symmetry. And the way that I find the axis of symmetry is the little equation x equals negative b over 2a. And our a and b, so the a, that is the leading coefficient here. And although we don't have a leading coefficient written in there, it is 1. It's a 1x squared. That's our a value. Our b value is the coefficient in front of our x term, and it's a positive 4. So I can use that little equation to find the axis of symmetry. So we have negative b, which is negative 4, over 2 times a, 2 times 1. That turns out to be negative 4 over 2, which is negative 2. So that says that our axis of symmetry is this line right here. That's the axis. Hey, why don't I draw it in there? Sure. I'm going to use pink here to show that x equals 2 is our axis of symmetry. Negative 2, excuse me. So right there, x equals negative 2. Because that's our axis of symmetry, I can take this point and reflect it across the axis, noticing that it's 2 units away, 2 horizontal units away from the axis of symmetry. And so then there's going to be another point right there reflected across the axis. So it'll be right there. Now the next thing that I can do is I can use the input, the x value for our axis of symmetry, and plug it into our equation. Y is equal to negative 2 squared. I'm going to find the y value here. This will tell us the vertex. Plus 4 times negative 2 plus 8. So we have y is equal to, well, negative 2 squared is 4. And then I'm going to do this multiplication here right now as well. 4 times negative 2, that's going to be negative 8. I could say plus a negative 8, but I think that just 4 minus 8 is easier. And then plus 8. Now 4 minus 8, that's going to be negative 4 plus 8. And negative 4 plus 8 is positive 4. So that tells me that my vertex is the point negative 2, positive 4. And so I can take that point right here, negative 2, positive 4, and that will be my vertex. Now I can draw in the parabola. It's just going to be a little sketch here. That it's not perfect. It's good enough. Just want to get the general idea for how to get a few points on the graph and draw in the graph from an equation. Next, what are the x-intercepts of that parabola? Don't make this more difficult than what it's actually asking for. There's an x-intercept, and there's an x-intercept. So one of the x-intercepts is the point negative 3, 0, and the other x-intercept is the point 1, 0. And that's all it is looking for. X-intercepts, remember, are those places on the graph that cross the x-axis. So those are the x-intercepts. And the y-intercept, it doesn't ask about it here, but the y-intercept is where the graph crosses the y-axis. The ball is thrown upward from the ground. The height of the ball is modeled by the function h of t is equal to negative 5t squared plus 20t, where t equals the time in seconds and h of t represents the height of the ball at time t seconds. What is the axis of symmetry and how does it relate to the time the ball is in the air? Again, remember the equation for the axis of symmetry is negative b over 2a. And so I'll write that in here. Sorry about that. X is equal to negative b over 2a. And so here we have our a value is this negative 5, and our b value is this positive 20. So our equation will be negative 20 over 2 times a is negative 5. That's going to be negative 20 over negative 10, which is equal to 2. So x equals 2 is the axis of symmetry. Now, to think about what this means, so think about when we throw a ball from the ground, it goes like this. Let me see if I can draw it a little more like a parabola. That's not great, but I think it's close enough. Here's the ground where we throw the ball from. Here's the ground where the ball lands. The axis of symmetry shows this left-hand side of the parabola reflects to the same other side of the parabola. And so what this means is, well, also, if we plugged in 0 for t, we would see that the x-axis is right here. Excuse me, the y-axis. The y-axis is right there, and this is the x-axis. So at 0, 0, the ball is on the ground, and then it leaves the ground, and at its maximum height, it's been in the air for 2 seconds, and it's been increasing for 2 seconds, and then it starts decreasing in height for 2 seconds. So it takes 2 seconds for the ball to increase to its maximum height. And another 2 seconds to fall back down to the ground. And that's how the ball, it says how does it relate to the time the ball is in the air, and that's what that means. So this is 4 seconds, so the point there is the point 40. All right. Sorry about that. Write the function in factored form so that it helps us see where the x-intercepts on the graph are. Oh, well, when I look at this function, what I notice is that this is a difference of squares. 25 is 5 squared, and we have x squared, and 9 is 3 squared. So it's a difference subtraction of 2 squares. Now, when we have a difference of squares, it always factors in the same way. We take the square root of, well, I should say the square root of this, of the first term. So 25, square root of 25 is 5, and they go there and there. And then we have x and x because the square root of x squared is x. And then we always have a plus and a minus, or addition and subtraction. And then we take the square root of 9. It's going to be 3 and 3. And that is how we factor a difference of squares. Now, this helps us to see where the x-intercepts on the graph are, because we can set this equal to 0, solve for x. That will give us one of our x-intercepts. Set this to 0, solve for x. That will give us the other x-intercept. And that's the first page. Number 5. Complete the square to transform the expression x squared plus 8x plus 1 into the form a times the quantity x minus h squared plus k. Now, it's some people have a hard time completing the square. It's a process you can use, and here's what I do that seems to help me. I break the equation into the first two terms with a blank inside parentheses. So notice I just took these two terms, I put them inside parentheses, and I left a blank. And then I take the last term, the plus 1 here, in the constant, and put it outside parentheses, and then another blank. So I've just set up the equation, or excuse me, the expression in such a way that I'm going to be able to complete the square more easily. So what I do is I take this, and you can just take the 8. You don't have to worry about if it's positive or negative, because we're going to end up squaring part of it anyway, so it's not going to matter. So we take the 8, divide it by 2, and square the result. And that's why, even if this was subtraction, you only take that number. You could make it a negative, but it doesn't really make any difference, because we're squaring it, and that will make it positive. So in this case, we have 8 divided by 2 is 4, squared, which is 16. Now, what we do is we take that 16, and we plug it right in there. It's a positive, always a positive 16. And now, we've added 16 to this expression, but we don't want to change the value of the expression. We want the value to remain the same, which means we need to balance by subtracting 16. That way, these two make a 0 together, and we have not changed the value of the expression. Now we're going to take that entire expression. We're going to rewrite it down here. This is going to get factored, and we can always factor it in the same way. There are some nice things about it that we can see. Notice that the square root of this is half of that. Yeah, we made it that way with this process. And that means that we can always just do, since this is just an x, we can just do x plus 4 times the quantity x plus 4. And then on the outside here, we have plus 1 minus 16 is minus 15. Now, you can see that this is the same thing multiplied by itself, which means we're going to have the quantity x plus 4 squared minus 15. And that now is in the correct form here. If we were graphing, this would be called vertex form, because HK would be the vertex of our parabola. It's a really nice form for graphing quadratics, especially if you started with standard form. So here you have the vertex, here you have a y-intercept, and you have a lot of information about the graph. Solve that equation, round your answer to the nearest hundredth. All right, well, the first thing I'm going to do here is so I need to get this x isolated on one side. It's already on the left-hand side here. So I need to undo operations in order to get it by itself. And the first thing I'm going to do is I'm going to add 28 here and bring this down. So I will have 4 times the quantity x plus 3 squared is equal to 28. Now, we're doing the reverse PEMDAS, which is SADMAP. So here the next thing I'm going to do is I'm going to do multiplication. So it's subtraction and addition are the first things, and that's why I did this first, SADMAP. Now multiplication and division. So I'm going to divide by 4, and that will give me the quantity x plus 3 squared is equal to 7. So this 4 divided by 4, that makes a 1. And then 28 divided by 4 gives us the 7. Now, the next thing I have outside of parentheses is the power of 2. So to undo a power of 2, I square root. And when I square root, on the left-hand side, I just have the quantity, or I just have x plus 3 is equal to. Now I have a positive and negative because I've square rooted, and I get 7. Positive and negative square root 7. Last thing I can do, or need to do, to isolate my x is subtract 3. Subtract 3. And I will have x is equal to positive and negative square root 7 minus 3. Now, if you wrote negative 3 plus and minus square root 7, that's just fine. Either way works. Doesn't really matter. But notice that I do have a positive and negative, so I need to now split this into two different situations. X is equal to square root 7 minus 3. And x is equal to negative square root 7 minus 3. So I'm going to need a calculator here now, so let's pull up a calculator. And here we go. So we have a square root 7 minus 3. And so that's going to be, x is approximately equal to, so I use that kind of a squiggly equal sign, negative 0.35, because I'm supposed to round to the nearest hundredth. So negative 0.35. So this is the tenths position, because it's right after the decimal, and the hundredths position. So that's one of my solutions. And then the other one is going to be 7 square root, and I'm going to make that a negative minus 3. And so I'll get x is approximately equal to negative 5.65. So I'm going to round to that hundredth spot right here. Because the digit after it, the unit, is a 5, we'll round up there. So those are our answers. Just mark those as solutions, and that's good. Find the vertex of the function by completing the square. Completing the square is a big part of this, so yeah, it makes sense that we have to do it a few times. I'm going to leave it in function notation. Put the first two terms into the parentheses, and the constant, and another space. So I'm going to take the 4, and I do 4 divided by 2, and I'm going to square that, and that's going to be 2 squared is equal to 4. So I'm going to take that 4, plug it into the blank, and then I'm going to balance the expression by subtracting 4. Alright, so now I'm going to take the function, I'm going to factor what's in the parentheses and combine what's not in the parentheses. You can use any method of factoring that you want. Factoring by grouping, the generic rectangle diamond problem, or the Xbox. Or just remember that because we have x squared here, this is just going to be x. And then we take the square root of this, so plus 4, plus 2. And it's going to factor to exactly the same. And then we have minus 6. Now we can see that we have the quantity x plus 2 times itself, so that's squaring minus 6, and we have completed the square. Alright. Solve each equation with the quadratic formula. Oh, the quadratic formula, what fun! So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. All of that is under the square root. And all of this that I've written so far is in the numerator of a fraction. and it's all over 2a. And the a here and there, oops, what happened there? The a, the b, and the c are coefficients in our equations. So the a is the leading coefficient, and if it's not written in, then it's just 1. The b value is the coefficient in front of our the x or b. It's called the linear term. And our c is the constant. Conveniently, c is for constant. So in this situation, we have x equals negative b plus or minus the square root of b squared minus 4ac, and I often do have to extend that square root. I needed to again this time. And that's all over 2a, like that. Now you could just put that straight in your calculator with an addition here, and then find the answer and go back in and replace it with a subtraction. I'm going to simplify this down a bit. I think it's useful to be able to do that by hand. So we have negative 2 plus or minus the square root of b squared, that's 4. And now I have subtract 4 times 1 times negative 8. Well, that's going to be negative 32. So I'm subtracting a negative 32, which is the same as adding 32. And then all of that is over 2. Now I have x is equal to negative 2 plus or minus the square root of 36. Oh, what a lucky coincidence that is. 36 is a perfect square. And so that is going to be negative 2 plus or minus 6, because the square root of 36 is 6, over 2. Now I can break this into two different equations. X is equal to negative 2 plus 6 over 2. And x is equal to negative 2 minus 6 over 2. And then I can just finish each of those. X is equal to 4 over 2. And that's x is equal to 2. X is equal to negative 8 over 2. And that is x equals negative 4. So those are the, oh, I should have had b the whole way. I'll go in and fix that right here at the end, because b is what is the variable that we're looking at through all of this. So it's okay that I've used x all the way down, as long as I make sure I know what I'm solving for there. So those are the values of b that will make this equation true. All right, now we're going to use the quadratic formula again. And I'm going to use x here as we're solving it, because b is one of our parameters. And so I don't want to make things more confusing by saying b is equal to all of this. Whoops. So we're going to make sure that we have all of our values here identified. So we have A, B, and C. I could mark it like that last time. Sorry I didn't. I think it's useful. X equals negative B plus or minus the square root of B squared minus 4AC. See, I do almost always need to extend it. Over 2a positive 1. Sorry about that. All right, and so we have negative 6 plus or minus the square root. 6 squared is 36. And again, we have subtract negative 32 will be plus 32. And all of that will be over 2. So we have x is equal to negative 6. Add addition or subtraction, plus or minus 68. That is not super handy. All over 2. So I could, let's see. Yeah, this could be simplified. This square root 68 could be kind of written in a different form with some numbers outside of the square root. But I'm actually just going to use the calculator from right here. So we're going to split this into two things here. Negative 6 plus square root 68 over 2. And x is equal to negative 6 minus square root 68 all over 2. So the first one here, let's see, maybe I'll move this over. So first thing I'm going to do is I'm going to actually do, all right, 6 negative plus the square root of 68. And now I have to hit equals to find out what all of that equals. And now I'm going to divide all of that by 2. And so my answer is going to be x is approximately equal to 1.12. And the next one is going to be negative 6 minus square root 68 divided by 2. Oops, I should have scooted this over so that you could see that this is actually what I was doing. And my answer is x is approximately equal to negative 7.12. And that is using the quadratic formula to answer questions. And the last thing here is the answers. I hope this has been useful for you. And if you have questions, make sure you come to class and check in, and we can go over some math. Take care, everybody. Have a good day.